Hi, kids. All right, we're going to go through some energy conversion. You should find this in your packet. But the first one is an object is heated, and then eventually it gives off some light. So we need an object. So, all right, so remember in physics, you got to be able to draw your picture, okay? And then mathematically explain it, and then also explain it with words. So let's have our random object. There is our random object, and then we are going to heat it. So there is some fire, some heat being added to this object. So most of the time in physics, and we're going to learn this later when we do our thermo unit, but the symbol for heat is going to be Q. Okay? So in this case, you would start with Q, and then eventually you're going to have so much heat that you are going to give off photons of light. And you should know at this point that photons are going to be HF, and you're still going to be, you're starting with some heat, and you're going to be ending with a smaller heat, so I'll call this like Q1, and I'll call this Q2, and then assuming your system is closed, meaning nothing is entering or exiting your system, then this is what it should look like. Okay, so heat, this would be a smaller amount of heat, and then HF for this. Okay, hopefully that makes sense. All right, you have a hand generator, and it's going to cause a bulb to light, so I have my flashlight here. Pretty exciting, isn't that? Okay. So let's draw that. So here is my flashlight. Here's the little crank thing, and then here would be the light part. Remember, I did minor in art. So to start, this is moving back and forth, and then to end, you're getting light being given off here. Okay, so if we're starting here, you would have kinetic energy because it's moving, and then you're ending up with HF because light, and you would probably also have some heat because if you wanted to call that, I guess we could call it Q, but it's usually when you add heat, that's where you get Q. So if it's like wasted heat, I'm just going to call this heat, and I would get that. Okay. If this thing it's not. If it was a perfect generator and there is no friction or anything else in this, then it would just be K equals HF. Okay. And then our last one, and just, okay, for kinetic. Last one, electron is moving between two oppositely charged plates. So I need to have two plates here. There's one plate. There's the other plate. Here is my electron. My electron is going to be moving this way. Well, if my electron is slowing down, this plate would have to be negatively charged, and this plate would have to be positively charged. Because if it's the other way, then my electron would be speeding up. Okay, so this would be my start, and then my end would be my electron is over here, and it has stopped. Okay, that's my electron. All right, so if I start with this, well, what type of energy do I have here? Well, my electron is moving, so I have kinetic energy. What type of energy do I have here? Well, I have potential energy, but it's obviously not potential energy due to gravity. It's going to be potential energy due to the electric charge. And assuming that, again, it's a closed system, this equals this. Hopefully you remember this is true, where you would have to look up the mass of an electron. Remember, though, on your formula sheet, the mass of an electron is here. Okay. And then this is going to be, if you look on your formula sheet, do you see where it says UE equals Q times delta V? This delta V is the change in voltage. So it would be, so you would have to know what the voltage is from here to here. Okay. So for example, if it's 100 volts from there to there, that's what that would be, assuming the electron moves the whole way. If the electron only moved half the way, if this was 100 volts, that would be 50 volts. Okay? But that should be good. Bye, kids!